is Tyagarajan from Pratyush Engineering College from the Department of Computer Science and Engineering. Today we are going to discuss about dividend conquer algorithm. Before going to discuss about dividend conquer algorithm examples, first of all we want to know what is dividend conquer. Say for example, if you have a problem, I am going to divide the problem into n number of sub-problems. So why the reason we go for dividend conquer algorithm in the sense, first of all we want to reduce the complexity of the problem, that's the thing. So if you want to reduce the complexity of the problem, so we are going to reduce complexity, then we are going to have a method of conquer as well as combination. So the thing is, we are going to divide an instance of problem into two or more small instances. Then we are going to solve the smaller instances recursively. It is said to be a conquer. So then if after solving the smaller instances and we are going to make a combination, that is said to be dividend conquer strategy. Then the next one is, actually we are going to discuss the dividend conquer in terms of, for example, you take a problem is the size of n. So I am going to divide this problem into two problems, say for subproblem n divided by 2 as well as the second one subproblem of n divided by 2. So after dividing the subproblem of 1 and 2, that is first half and the second half, we are going to make a conquer one. Conquer in the sense I am going to solve it recursively, that is a subproblem recursively and once again a subproblem recursively, and after solving we are going to make a combination, that is the solution of each and every subproblem is combined into a global problem, that is the original solution. So it is said to be the solution of the original problem. So this is said to be dividend conquer strategy. And then the next one, for example, we are going to discuss some examples for dividend conquer strategy. So say for example, we have an example of merge sort and quick sort and binary tree traversals and multiplication of large integers. So the next one is matrix multiplication. It is said to be Strassman's multiplication. And the closest pair and convex hull algorithm, and the next one is binary search algorithm. So we are going to discuss some examples. Say for example, I move for the first one. So an example of merge sort. So before that, we want to know the function, that is a dividend conquer. It is said to be a function of t of n which is equal to a of t n divided by b plus f of n. Here we are going to say a and b are said to be a constant and f of n is nothing but a function. So it is said to be a derivation of Master's theorem. So a derivation of Master's theorem is used to know how the dividend conquer strategy will be. Say for example, if the Master's theorem states we have some three classes. The first class is if a less than b power d, where t of n belongs to theta of n power d, and if a equal to b power d, t of n belongs to belongs to theta of n power d log n. And if a greater than b power d, t of n belongs to theta of n log ba. So for example, we take this example, t of n equal to 4t n divided by 2 plus n. So this is a function. So first of all we want to know a and b. So say for example, a is equal to 4 and b equal to 2 and the function f of n is said to be n. So before going to know the value of t of n, first of all we are going to derive this function. Say for example, a into t n divided by b. So a is 4 and b is said to be 2. So I want to know whether a is less than b or greater than b or it is equal to a, that is equal to b. So for the given example, I am going to say a equal to 4 and b equal to 2. So a is greater than b power d. If a is greater than b power d, where t of n belongs to theta of n log ba. So what is the value for t of n we are getting? The thing is we are getting some t of n equal to theta of n square. That is the thing. So you go for the value a and b and substitute the value in the given function and f of n. So f of n is said to be n. You know the condition f of n belongs to theta of n power d. So I am going to say that d is nothing but 1. Okay. So thereby we are getting some value. So after substituting the value, anyway the value of d is greater than or equal to 0. That's the constraint. So based on the constraint we are going to substitute the value and finally we are getting t of n belongs to theta of n square. So that is output for this one. And likewise similarly we go for the same thing. But we want to know first of all the condition whether a equal to b power d or a is less than b power d or a is greater than b power d. So it states that is said to be Master's theorem. And we go for the examples. For example, we have some example by using the first example is merge sort example. So we have some n number of examples. The first thing is merge sort. So the strategy of merge sort algorithm is, so we have some n number of input value. I am going to divide the given input into two halves. First of all, I am going to divide the problem into two sub-instances, that is sub-problem 1 as well as sub-problem 2. So once you divide the problem, and once again I am going to divide the given problem, that is once again the sub-problem is divided into n number of sub-problems. Okay. Say for example, n equal to 8, first of all n1 equal to 4 and n2 equal to 4, and once again n1 is divided further, n11 equal to 2 as well as n12 equal to 2. Okay. So like this we are going to divide the problem into some n number of sub-problems, at least the value of equal to 1 we are going to make it divide. So say for example, once again I am going to divide 8 and 3. Say for example 8 and 3, we are going to divide into 8 as well as 3, and once again 2 as well as 9 in the left half. Likewise in the right half also. And once again what we are going to do, first of all we are going to compare after dividing into small number of pieces. I am going to compare which one is greater and lesser one. So based upon that I am going to make it sort. So likewise we are going to sort the remaining input value, that is remaining halves, and finally we are going to combine. Actually our problem is divide, conquer as well as combination. Okay. So this is said to be dividing and this is said to be recursively I am going to do the operation, that is said to be conquer, and it is said to be combined, that is a combination one. After combining both of the halves, left half and right half, I want to make a merging operation. Before going to have the merging operation, we want to know whether it must be must be in the ascending order, that is in the non-decreasing order. Okay, it must be in ascending order only. So before going to combine both of the half, once again I am going to check whether my input values are in the correct location or not. For example, if I am going to combine both the value, I want to my value is nothing but the ascending one, that is an increasing order one, that is my output. So how I am getting this? For example, take this merge sort. So initially what we are going to do, we are going to split the array into, first of all the input value is a of 0 to n minus 1. I am going to divide the halves into two halves, okay, and then make the copy of each half as P as well as C, an array of B as well as array of C. So I am going to perform the sorting arrays, that is the sort the arrays B and C recursively. It is said to be conquer operation, and merge sorted arrays B and C in an array of A as follows. So say for example, you look at this diagram. Actually, initially it is said to be the first half and the second half, this is said to be B and it is said to be C, and after combining the value it is said to be the value of output value is nothing but A. So we take this algorithm. First of all I am going to perform the values of B as well as value of C. After combining, the output value is said to be array of A. We are going to follow the steps. The first step is compare the first element in the remaining unprocessed portion of the array and copy the smaller element of the 2 into A. While incrementing the index, we are going to indicating the unprocessed portion of that array. So that is the thing is, for example, I am going to say that, so this is 2 and we have 1. First of all, I am going to compare which one is the smallest one. The smallest element must be in the first portion of the output array. It is said to be B and it is said to be C and it is said to be an output array of A. So like this, similarly we are going to compare the left half with the right half and we are going to arrange the output in the ascending order. That is the thing. So, and look at this algorithm, that is a merging algorithm, it's a merge sort algorithm. Whatever we discussed, we are going to repeat the same in this algorithm. The input is nothing but, the entire element is nothing but input, that is said to be A of 0 to n minus 1 of ordered elements, as well as output we are getting, that is nothing but non-decreasing order, that is said to be an increasing order one. So what we are going to do, the left half of copy the value of A of 0 to n divided by 2, that is the first half, okay. So we are going to copy A to B as well as once again the right half, we are going to copy into A to C, and finally we are going to perform the merge sort operation B as well as C separately, and after that we are going to, so actually this is said to be conquer operation. So we are here we are going to make it conquer, and finally we are going to perform merging operation, that is said to be the output of B, C, A. The overall conclusion is, if suppose we have a problem, it may be a complex one, we are going to divide the problem first of all and make it conquer, and finally we are going to combine. So like this we are having some n number of examples, just like some quick start or maybe some binary search algorithm like that. Okay, fine, that's all, thank you.